Hello.
Hello.
Okay.
So hey, Elliot, how you doing? Sorry, I neglected the fact that you were there.
Yeah.
How are you doing?
I'm good.
I can't hear you in case your mic. Oh, maybe it's me.
Can you hear me?
Great, I can hear you.
Hi.
I'm joined here with Jacques.
Hey, how are you?
Good. And you?
Fine.
What's the confinement?
And it's kind of boring, but I still have a lot of work to do for my uni. So.
Oh, yeah, it's terrible.
Hi, hello.
Hello.
And I can see Sarah on the screen.
Hi.
Hi, Sarah. How are you?
Good. Nice to meet you.
Pleasure to meet you, Michael, Jacques.
Hey.
Hello.
Elliot.
So you work at the Harbour School.
Yes.
Great. And what's your? There's about 4 different people at the Harbour School sort of joining in and out. What's your background? It was
Marine biology.
Marine biology. Yeah, I thought so. Ming introduced you via email a little while ago, but nice to put the face to the name.
Yes.
And Ming's here, and Maxine is here. Maxine.
Yes, I'm here. Yes.
Hi.
Hi.
Thanks for your excellent work during the week.
Yeah, it was amazing.
Posted.
Oh, thank you.
Yeah. We certainly need a coral expert, so thank you so much for that.
Thank you. I uploaded that folder to the drive you sent me.
Oh, thank you so much. Let me look for it now. Thank you. And how's everyone's week been?
Very good, except for the rain. Today I finally got outside in the sun for a bit.
Oh yeah, lunchtime just perfectly was nice and sunny, so that was really nice. So I think we'll just wait for Cesar. We were just talking to him on another line, and we'll just wait till he joins. But
Right.
and Ming is there. So all you guys. Oh, and we've got a no worries. You stay, Ming. And we've got a new member. I would just like to meet. I'm sorry, I don't know how to pronounce your name, and I'm not sure we met. Sharvasti. And Paul. Hi, Paul. I was just wondering, and Cesar. Oops.
Oh, cool.
I was just wondering if we could hear, and Sanju is just joining.
Hey,
Hey Ming, how are you doing?
you want to see something?
Yes, a round little disc.
Oh, cool.
Fix the 3D printer.
Whoa.
Oh my God.
What are you doing?
Both of the 3D printer needed servicing because, you know, this part extruder head, both of them are pretty, like the way that the manufacturer print them, they're like, you can see is like, the grain is like horizontal. So just like, it doesn't support weight over time. So like they both broke and I had to like glue them back together. And that's the first one I put back together. And now I'm gonna put the second one back together later.
Well
Anyway.
done, Mega Ming. Excellent. So how come you're at school and the rest of the THS people are at home?
We take turns
Oh, really?
and we
Okay.
can't stand each other personally.
It's also 7 p.m. So,
Yeah. Oh, okay. So otherwise you're at school. Okay.
yeah.
So I was wondering, just before we get started, if we meet our new DIY droner, Sharvasti. Are you there? You emailed me today. Okay, too shy, but you can chat. Oh, hi. You can chat on there. Great. Well, nice to have you, Sharvasti. Shara or Shra. Okay, great. Well, and Sanju is here, so I suppose he'll chime in a bit later on his part, but we should just give our update from this end. So me and Jack have been working very hard on our respective parts, me on mechanical assembly, and I've designing a new CAD model that fits the exact specs. Like the previous CAD model was really just made up dimensions floating in the air. Now we have a CAD model that if we want to go to rapid prototyping, parts will actually fit in real terms. And Jack has been busy on the electric, well, let Jack explain.
Oh yeah, I have been designing the electrical assembly, so now it's cleaner, and I also made some diagrams for the electrical assembly in order for the documentation, so that anyone can replicate it. So yeah, that's pretty much it.
I was wondering if we could go around the room and see if anyone else had an update. I know Ming had an update, her laser cut part. Beautiful. Adele.
Hi, Michael. How are you doing?
Good, thanks. How are you?
I'm doing good. I have a quick update. I just uploaded on GitHub some TensorFlow templates for the image recognition parts that we may be able to try out. I think that's something that we discussed last week.
Sure. And can you tell me whereabouts you put them?
So if you go at the root of your GitHub, there should be an image recognition folder. Project.
Okay, how about I share screen?
Maker Bay image recognition.
Okay, so this is the home page.
Yeah, that's it. So I also documented a bit on how to download the TensorFlow and some comments. There is two sets of files, one for the training and always a couple of files. So one for the training and one for the prediction, which is the actual image recognition. And I have also uploaded some collab notebook, collab notebook, which is for Google Cloud, so for Google TensorFlow, the collaboratory part.
Okay, could you just please reiterate where I'm looking in the archive?
Okay, so if you're looking on the archive, you have first the README, which is the kind of documentation, high level.
Mm-hmm.
Okay, and then you have two files with the extension IPYNB.
Is it in one of these 6 folders, mechanical, electrical, boat, PC, cloud?
Yeah, I'm sorry. So I said there is two files for two PY files, which are standalone files, which can be run directly on your laptop. And there is two IPYNB files that you can just put on Google Collaboratory. It's something that you can access from Google Drive and execute on Google server to create your machine learning model and as well as doing the prediction.
I think what Michael is asking is where is this data? Like, is there a link from the GitHub, or is it somewhere else? Or like, how do we know how can we find this file that you mentioned? Where is it?
You mean the images?
Yes.
No, I don't have the images. That's missing. That's the only part which is missing. So if you provide, yep, sorry.
Is it the one level up under image recognition? It's not under the Coral.
No, no, no. This is just the templates for the image recognition. Images with labels are missing, simply because first, I don't have Coral images, and I don't know all the asset classes, which are the labels. I mean, the name of the Coral that we want to recognize. So if you can provide this, I can complete. The code to do the recognition. So what I will need a set of images that contains of corals, of course, together with the labels. So basically, if there is one coral name, I think I got an example.
So if you just shared during the week, I believe.
Yeah. So if you scroll down the file system structure a bit below on the README, I explained that there is a folder called training data, which contains different name of asset class. And the name of asset class could be the name, for example, of one coral species. So, and inside this folder, you just put all images which can be used to recognize the particular coral species that you want to identify. So this will be your image classifier. And based on that, the prediction model will be able to further figure out any new images that you want to recognize. So if you want to have a test to be able to test that, I just need images with labels in the correct folder. And the folder has to have the name of the coral species that is shown on the picture. So again, it's not at this stage. This model cannot identify several species in the same images, but it can tell you that it recognizes one species in one image with a certain percentage of accuracy. But it's a good start.
Sorry, can I say something? I saw that someone already had the pictures I gave you on the GitHub.
I just put the link in the chat, which that's where Maxine put your image, correct?
Okay. So I think just a matter of coordination. So it seems that you have the images. So just need to try it out. And probably for the coming week, I'm going to quickly try to do this on Google.
Okay, fantastic. Well, if either we have a conversation tomorrow, Adele, and or after the meeting, if you look at the link where Maxine has uploaded the photos with the images, then see if that's something you can work with.
Yep, anytime tomorrow.
Okay, thanks. So let's bump around the room. If anyone else has an update of something they can share. I was thinking of sharing my screen.
Looks like a turtle.
And I've been working on making a 3D turtle. Can you all see my screen?
Looks nice.
So this is the tube frame, which we have today, but this one's actually made to spec, so it should be able to be manufacturable and fit this foam pontoon, which is not nearly finished, but will house 2 batteries, so they provide weight there. The larger 4-inch tube, which we've already done the electrical assembly to. We need to do the CAD model of that electrical assembly, which I'm working on, and we need to make some sort of thruster sub-assembly so the thrusters can come on and off together easily, so you're not fiddling around with little screws. And it sort of looks like a turtle. And if anyone else, Sanju, I was wondering if you had an update.
I have some questions about the design. Sorry. The first question is, so I can see the hole. So I imagine there are cables that pop out of the tube at the bottom, and then we connect to something on the top. Is that correct?
Correct.
So what is on the top and what is in the bottom in terms of components? Like, are the communication like GPS on the top? Do they have like their own compartments, or are they underwater?
Sure. So GPS, the receiver, the radio receiver, and telemetry are all on some sort of aerial stand above the boat, above the phone pontoon. The batteries are in the pontoon, and the rest of the electronics, like the Pixhawk, are in the tube under the water.
I see. Because the heaviest part is the battery. And so ideally, the lower you put the heaviest part, the better. Like ideally, you put the battery as low as possible because it will act as a stabilization. And the Pixhawk, some of the components, the cables are quite short. So it's going to be difficult to, if you have the Pixhawk underwater, it means they would have to put long wires going all the way to the top, which means you're going to have a lot of wires coming out.
So Chuck's already made an extension for the GPS, but the Pixhawk and the receiver are due to make an extension.
Yeah.
Like we need to make extensions anyway, because you need to get the telemetry and the GPS a meter sort of from each other, or as wide as you can on the boat frame as possible. So they need extensions anyway. And the dependent for that, like the hold up, is buying more of these red cable penetrators. That's the hold up. They're coming in the post, and they should be with us in the next few days.
And for the GPS, now it looks like we basically added up some Arduino cables, so it can be plugged and unplugged more easily. We basically make it, yeah, we're transforming the brain, so the drone casing, in order to have like an easier plugging and unplugging.
I see.
But for the battery, we have been looking, and we are still looking at ways to put it inside. We're gonna have to see, like, if we move some parts away. I don't know if you guys can all see the. Yeah, we will have to. Where's the battery? Yeah, what's. The battery is very, very big compared to the space available.
Yes.
So we will have to see how we put it in. But otherwise, we'll look at a way to put it underwater, or at least like the lowest possible.
This is an open conversation, so we're just brainstorming where to have. I agree that we should have batteries low, but I don't agree that we should have batteries in the tube, because according to other ocean robotics people, you don't want to be opening the tube on the day of a test or on the day of a mapping. And you want the chance to change a battery. So this means you don't want to open the tube, but you want to have batteries that can be modular. So yes, you might want batteries to be underwater, but not in the tube. I think you're on mute, Cesar.
Another consideration is the stability. If you have a wave and the boat tips over and the battery is on the top, then the boat will stay upside down, just by virtue of, balance. So you have to just be aware that might happen. So when you do the flotation test in the tank, you might manage. But then if you have a wave and it tips over, then you might just stay upside down, and then all the communication will be on the water, and then you have no more communication with the vessel. It was just an observation, so.
That's a fair point. Please share me your observation of the testing we did at the beach together. Did you think that was stable, or like it would, if it got tipped over, it wouldn't tip back, or?
I think the main problem is that the telemetry was underwater. Telemetry. I think one of the main issues that the telemetry was underwater, communication underwater.
Yeah.
And so because the component that are very big is the battery, and it's going to be the camera, and both of these two components should be underwater, but everything else ideally would be above the water line, just for safety, so they can stay dry. And I think you want to put the Pixhawk and the communication in the same area. What is really creating a lot of noise is going to be the motors because of rotation, and then magnets, which are quite far and underwater. If you want to have really good range, then you want to put your GPS on a pole, as well as the telemetry. So that creates 3 areas, like dry and heavy, wet and heavy, underwater, camera and battery, all the computation above the water line, ideally. So even if there's a leakage, it would still, like, the whole robot wouldn't die. And then communication up top. Ideally, that's the ideal solution. Yeah.
Okay.
So just let me just recap: dry and heavy, then computation and communication, right?
That's the ideal, just for safety. So if you put your communication underwater, your range is going to be super small. If you put your battery on top, it's going to be super unstable. So you want to put the heavy stuff at the bottom, like computation just above waterline, and communication as high as you can, so you could have a very long range. That's, yeah.
The Pixhawk, the actual Pixhawk module can be underwater, and the radio receiver and the GPS and the telemetry.
It can, but the problem is that Pixhawk has so many connections, and the Pixhawk itself is very small. So Pixhawk is just this size, right? It's pretty small. So if you put a Pixhawk underwater and then you have to extend all the cable, that's a lot of cables coming out of your robot. So there's a lot of risk of flooding. There's a lot of risk of loss of power, lots of risk of leakage. So if the Pixhawk is small, then just put it with the rest of computation. Just put a battery underwater and the camera, which is what should be underwater.
Like this for everyone. It's this small module, so it's connected to basically everything.
Yeah, so you don't want that to be underwater, because if there's a flood, you lose everything.
But there's an issue because the Pixhawk is linked to the camera, and the camera length is sorry, no, the Pixhawk is not linked to the camera actually. Yeah, right. Yeah. But however, there's still an issue with the Raspberry Pi, which is as fragile compared to weather, and has to be underwater, or at least at the shallow side, because the camera has to be underwater.
Well, maybe we could use a USB. So the Pi cam, we could also use a really good quality webcam, for example, which is connected to USB. And then USB can be 3 meters. That's no problem. It can be up to 5 meters. And suddenly you have one cable going for the camera, and then another cable going for the battery. And you just have 2 cables instead of many.
Oh, so there's range limitations for the length of cables?
Yes, USB optimally is under 3 meters. Maximum range is 5 meters. If you go more than 5 meters, you will have a drop in voltage, and then you would have a lot of problems, and you'll be very unstable.
And what about the Pixhawk cables? For example, I'm thinking about the GPS. Is it okay if you have a 1 meter cable?
It's got the same kind of issue. 1 meter should be all right. You need to make sure that those cables are shielded. So it means that they are not too close to to the power. For example, the battery, they shouldn't be together. If you have a high voltage, high amperage together, then they might start to create some problems. So ideally they are separated or shielded. It means that there's something around the cable to protect it from electromagnetic influence, for basically because we're mixing power and data. So yeah.
Okay, thank you.
Yep.
Okay, we have to do a big reshuffle.
Sorry about that. I'm sorry for this. It was a long segment.
So what do you think should we reshuffle then?
Well, I think I did need to have a ponder about the batteries and the tube.
Right. Yeah, we have to see also in terms of complexity of how many cables go out of the tube. Yeah.
The less cable, the better.
Yeah.
So maybe I should put the stuff on hold, cause a little bit a big reshuffle.
So which stuff? The
like the stuff that you did reprint.
The 3D printing was on hold anyway. I believe I emailed you, but the end cap is invaluable. I think we'll still need that many red cable penetrators, or at least we need the flexibility. So the laser cut part you did was that's still going to be needed regardless of where batteries go. And
Oh, sorry. I didn't know there was an email about the 3D printer.
Okay,
Anyway, I just fixed the 3D printer. It doesn't really matter. It's cool.
no, it matters. We definitely need that. We definitely need.
The plates and the dividers that you are printing, maybe even if there's only 2 cables coming out, they can still be useful, because it's really good that you have a way to organize the cable and the space in the tube under the water, because maybe in the future there'll be more sensors. Right now it's rather simple. There's just like the potentially the camera and then the battery, but there might be environmental sensors in the future in that compartment. So it's really good that you have a plate with holes like what you guys have designed, where you have more real estate, which is a good thing.
Mm-hmm.
Yeah.
Okay.
What I'm saying is that you could still print it, and even if we don't use all the parts, it's still very useful.
Okay, so how about like at some point we just revisit what I really need to print, and then it'll be cool.
Can I ask a question?
Sure.
How big is it in the CAD drawing? What are the dimensions?
Let me show you a scale model on my desk,
Oh,
and just tell you that's roughly 400. Can you get the perspective of scale there? My head's normal size head.
So how much bigger? 400 times?
Yeah. So this, 400 mil, probably like half a meter long.
Oh, okay.
Yeah.
Nice.
And this is roughly 400, probably 35 or something, maybe half a meter and 40 that way.
Awesome.
So we have to do a test on our first optical test, which we're not up to the point of, but we have to, I've tried to make it as small as possible so it can be transportable by scientists or teams like ours. But it may need to have some sort of wing riggers or something to make it wider on the surface of the water so the camera isn't wobbling as much. But we also have a gimbal on the camera to allow for that stabilization.
I was gonna say, could you make the top of it, like make it shallower in depth and then just attach a pole on the top for the GPS? Because that way, if it's so round, it's always gonna have trouble with flipping over unless you put a lot of weight under it. So like if it's more flat on the top, so it doesn't roll.
Okay, yep.
And then, sorry, that's another question. Is this just to be used by individuals like ROV driving it around, or is this going to be eventually something that people can set out for, like, you know, and come back like days later and it would have mapped an entire area?
Days would be a stretch, but I would say 3 to 4 hours of battery would be our goal.
Oh, nice.
So we can set it on an autonomous mission and you be on a boat or a dock close and be monitoring its mission. I mean, you wouldn't really send it away, have a coffee. You would send it away with very cautious sort of monitoring, at least at the start.
That's awesome. Exciting.
If there's any more questions on electrical assembly, layout of components, mechanical design, we can have them in this informal segment, or we can jump to another section. In that case, I would like to jump to Sanju and see what can be done or what has been done on the AI side of things.
Yeah, so this week I was working on the software to do the labeling. Let me just show you. Yeah, can you see it?
It's coming up. Okay.
So this is a simulation, or you're fiddling with it now?
Yeah. So this is software. So it requires some setup. I'm fiddling with it now. So this is the software. So it's pretty basic. So getting it installed on a laptop, it takes like 4-5 steps. But after done, it's pretty basic. You just see, I create a box, and then I can edit the label. I can edit the label and just add whatever I want. So yeah, I was hoping to help Maxine set this up on her computer today, so that she can get started on labeling the images. So once you label them, it should save to your. It automatically saves as the file type that can store needs for model for training model. Yeah.
That's awesome. What is the tool that you're using for labeling images? Is this something that's on your local machine, or is this something that we could do online,
Yes,
or like collaboratively?
So right now it is on my local machine. I'm trying to. So there's a lot of solutions out there. But I'm trying to find something that can be done. That's more collaboration friendly. But this is actually GitHub repo. So you have to clone the repo and then download some dependencies, and then you can run it on your laptop, on your computer. Yeah. Yeah. Go on.
The reason I'm asking this is because if we want to collaborate, so let's say if you build a software on one end, and then on the other hand, you have biologists who are willing to volunteer some of their time to tag. If there's a platform where we can both like label things, maybe it would be a way that we can get more people to be involved, or members from the public, and get much more volume. But it also depends how many images do you need to have tags.
I think there is no limit on that, as many as possible. Yeah, it's only going to make it better.
What's the minimum?
Yeah, but see, for my last model, I didn't use a lot of images for the classification model. That I only used like I think 100 images for each class, and I got pretty good success rate. But again, so the thing is, I use species of coral that have like very clear distinction, so it is pretty easy for the software to recognize them. But if we move on to corals that look more alike, then obviously I would say like at least thousands of samples would be great. Yeah.
Because Maxine has prepared a really nice slideshow, which kind of shows the general categories. Did you see it?
Yeah, no, I haven't gotten a chance to look at it yet. I just downloaded it. Yeah.
I can add it to the chat.
It's on the GitHub actually.
Is it? Oh, good.
Yeah. Let me send you the link on the GitHub.
That's a good idea.
So. Oh, you're on it. Okay, great.
So if you're on the home page of the Coral Reef Mapping Drone, then there's 6 folders, and then the 6th one is biology. And if you go into biology, then there's Maxine's presentation. And or if you want a downloadable version of this, you can look at her PPT, her PowerPoint, which I put in the Google Drive, which she put in the Google Drive. I put the link in the chat.
This one.
Sanju, do you want to add some more, or maybe you want to see what the presentation? Maybe Maxine can elaborate on the deck she prepared.
Yeah, I'm going through it right now.
Okay.
So yeah, I do have some questions ready to ask this. Yeah.
Great.
Yeah. I think, yeah, I think going to these pictures, there's only a couple that I see, and I'm like, okay, like these are very similar, and these might cause problems. But in general, we talked about this last week as well. So one of the problems that I was having when I was training my last model was when I got zoomed in images, like when the image was very close to the camera, I was getting wrong classifications. Because, for example, if you know what a table color looks like, if it's very zoomed in, it looks like just individual stocks, which looks like a staghorn color, which is wrong classification. So again, yeah, I think the tough part will be distinct between the colors that are actually that look alike, but otherwise it should be fine. And beyond that, we also talked last week about the color health and all of that. And I think that's obviously going to be the next phase, but that should be fine as well. And that's mainly going to be based on the color of the image that we get. Yeah.
I'll be honest, I didn't catch everything, Sanjeev, but if you needed to talk directly with Maxine to get those photos, is that something that you could do?
Yeah, for sure.
Yeah, Sanjeev, I have like the website from where I got the photos. Is this big database with all corals around the world, and we can actually find photos that are zoomed in. So you can actually see the polyps of each coral species.
Yeah.
So maybe you can get we can get the photos directly from that database.
Yeah.
Maxine, do you have a link to that database, or is that already?
Actually, it's on the PowerPoint. Yeah, it's the first link there. It's called Corals of the World.
Great, thanks.
Yeah, I cannot share it now because I don't know why my computer is not working, so I'm using my phone.
Yep, that's fine. I found it here. That's fine. Oh, yes.
Have we decided on a camera that we're going to use?
For the moment, we're prototyping with the Raspberry Pi camera.
Yeah, we still have to get it started. Actually, it's not even connected to the drone for now. Now the drone is just like a RC boat, basically, but it doesn't have vision yet. So, by the way, this is a call to skills and yeah, if you guys have any ideas and like have already worked with Raspberry Pis, we would be very much looking forward to have some help on making the most out of for the vision part of the drone. For example, Cesar was mentioning the possibility of adding a USB webcam instead of a normal camera for the Raspberry Pi.
Also, I think for a lot of the AI, for like recognizing coral, it doesn't all have to be done on board because it's pretty computationally intensive, because you need to have thousands of images and NDI. So the other way to look at it is that we take really good pictures underwater, and then once we bring it back on land, we take the SD card with gigabytes of picture, and then on the land we can do the classification. I imagine that would be, or at the beginning at least. Maybe in the future we can have an amazing machine and it can like classify on the fly. But in the early steps, it's probably wiser to start on land because it's a large amount of data and we haven't trained the machine learning yet.
Yeah, that's what I did.
Yeah, that's definitely going to be.
Oh, sorry.
No, go on.
Sorry, I said I did that like before we took photos of corals, like photos of different parts of the coral reef, and then once on land, then we could identify the corals from the computer, from the photos, basically. So you can zoom in, and then it's easier to, even if the picture that the drone takes is quite, like the coral seems far away, once you do it like on land, you can zoom in, and then it's easier to identify them.
And Cesar, to respond to the computational power on land, what does that look like? Like, what program is that, or whose software, or?
So that comes back to the previous kind of comment. Like, I think this is going to be more a question for Adele, because she's really like the specialist of like database and stuff. But I think in the at the beginning when we prototype it, Sanju mentioned that there are some websites where you can do collaborative labeling. And so like this, for example, we could say upload a lot of this image on this kind of websites. Or I think some of them also manage Google Drive. So they just have a Google Drive, and then you create just a text file, which is like a labeling file, which is kind of a set of coordinates, what part of the image is what. And so at least we could have a lot of other people from outside helping us. I would say for training the machine learning, that might be the most efficient. And then maybe later when that is super streamlined, then we can move the algorithm to our own AWS or like our own clouds, where we can have a lot of volume of data being processed. But I think at the beginning, because we're still in prototyping phase of the machine learning, it might be easier to use collaborative tools just to prototype for the moment and to train the algorithm. But that's just my intuition. But I'm not a specialist, so I rely heavily on Sanju and Adele.
Yeah, so for the training itself, especially in the beginning, I don't think we'll be getting too many pictures. There's, we can, even for that, we can use some cloud computing, and there's even, we can even use online GPUs, graphical processor unit. It's, they offer free services, which is not great, but it should be enough for just prototyping. And beyond that, I think we won't need anything other than just using AWS, something like that. That should be enough.
That would be amazing. Is there a possibility to connect the piece of information that you know, for example, like what is the software you want to use, or the labeling software, or the collaboration platform, or the server, the computation power you want to use? Could you write this just as maybe as a bullet list into the GitHub, so that this we start to have an idea of like what you have on your mind in terms of implementation?
Yeah, sure. I'll just add it to the README file. Yeah.
So I'm just sharing my screen, Sanju, and anything anything related to cloud and AI can go in folder 5, and or if you make an issue, you can make a new issue here if it's sort of a micro task for someone to pick up, or to alert someone, like you can assign a person to it. So you can assign someone like, hey, Cesar, look at this software, or myself, or so please, everyone, if you have the skills, look at this list of issues that we're looking for help with and how we can collaborate on it. And there's short explanations, so you can, if you don't understand it, you can reach out.
No. Do you have any other things to, has anyone got any work or updates to share? Otherwise, we can share with you what we did on documentation, maybe, or
that's a good idea.
I don't know. Let me share my screen. Just a second. All right. Okay, it's working. All right. So with is it working? Yes. So we have started to build to make the building instructions for the drone. This document is not finished, but so we're making annotated pictures. For example, this one. So we're just basically putting out so that anyone can reconstruct it. And we did a big diagram with the whole assembly of the. All right. So we did with the whole. All right, with the whole assembly. So yeah, that's pretty much it. So we have started to put it up on the GitHub. Let me find it. Okay, I lost the GitHub. Okay. So yeah, we have started to put it on the GitHub in the electric and electronics part. So yeah, just to give you an update about the documentation for the replication parts. So yeah, again, please, so you can easily create, or you can create a GitHub account and put up your updates in every single folder, so that yeah, we can share it with everyone. And we have a wiki part, which has wikis right here, which has the ongoing work. So yeah, that's pretty much it for this update.
So there's a couple of people that are new. I don't know Sarah, and I don't know Elliot is also new to this room. Maybe, and Shravasti as well. If you can hear us, if you could just make a quick introduction, because I think a lot of people don't. I mean, am I the only person who don't know you guys, or?
I'm new. I work at the Harbor School in the Marine Science Center. So my background's marine biology and ocean science. So I'm here to help with the coral identification, and I'm not much into electronics, so a little behind when you're talking about that. But hopefully I can help Maxine make a database, and we can upload all the photos and start putting all the species names.
You guys have a core. Do you have quite a few aquariums in the school? Do you have corals in your aquariums?
Yeah. We have a
Oh,
couple
wow.
that we actually got in Hong Kong. Technically, you're not supposed to without a permit, but they basically said, don't ask, don't tell. So we have a couple that we observed, 2 different species in our tank that are local, and then the rest we've purchased. So they're not exactly local, but they're Indo-Pacific species.
Are they? So I guess because in the aquarium they should be easy to photograph, right? Like if you have them at different angle with different kind of quality of lighting, we could.
Yeah, definitely. There's a lot of UV light, so we would have to turn all that off and get some regular photos without the UV, because otherwise the photos turn out all just blue and neon color. But yeah, so we can get some good pictures of those, and then
actually a lot of bad pictures is also helpful, isn't it, Sanju? Like a lot of bad pictures, maybe more helpful sometimes.
Yeah, we'll take anything we get.
The thing is, if I can say something, so the corals, the way they look in the aquarium, that's not how they look in the wild most of the time. Because especially in Hong Kong, the visibility is quite low, and the corals, they don't have that bright color underwater. So it's difficult to identify corals just using photos from an aquarium, because in the aquarium, of course, they look way better, and the colors are way more bright.
Yeah.
So I don't know if someone can use the photos that we take in the tank as a way to identify the ones in the wild.
Yeah.
Okay.
Yeah. Oh, we have to make your tank very dirty. You have to throw some mud in your tank to make it more look like how it's outside.
Yes.
So the visibility of water in the wild, in the ocean, changes, or on reefs, changes daily or weekly or monthly or seasonally. So is that something that we'll have to calibrate every time we go out for a mission? So set the AI to it's murky water or it's very cloudy water, or will it be one size fits all?
So that you can get sensors that you put in the water that measure the particles. So that would be the ultimate thing, is to match it up with the turbidity of the water. So you can tell the turbidity with a simple handheld thing that you can use from a boat called a Secchi disc.
Secchi disc.
Yeah, like SCHEECHI, I think.
Is it Italian? Maybe Maxine can help.
Yeah, maybe.
SECCHI.
There we go.
Couldn't guess that.
So yeah, depending on the turbidity would change the color of what you're seeing. So, but a lot of
sorry.
Oh, I was gonna say maybe the pictures, the AI could identify shapes and number of tentacles on the close-up images, because a lot of the hard corals are going to look the same color.
Mm. And so I've seen some softwares allowing for like image enhancement for corals. Are you aware that any of these are helpful actually, or it's like just useful for humans but not for AIs?
I'm not sure. I have no idea. I'm not sure how AI really works other than matching photos, right?
Right.
Yeah.
And so about the turbidity, does it change the color, or does it just make it foggy?
So it just makes it have less light. So less light means less color. So colors that are like usually bright orange would look like a dull brown.
And would it help to put eventually a pocket lamp on the?
What would actually help is if it had a light on it. So if you could have your own light source, that would at least ensure that even with TV, that it would light up the colors.
Cool. Thank you.
Are you going to do, like this drone, once people use it, they're going to use it in different places around Hong Kong, or it's always like, for example, Hoi Ha?
Yeah, ideally different places where anyone needs to map coral.
Yeah, okay. So like,
What's
for example,
the purpose?
maybe Hoi Ha has a very good visibility most of the time, but then if you use it somewhere else, the visibility can be lower.
And just another question about the lamp. Would it make the fish and eventually the species go away from the drone, or will they just remain unchanged?
A flashlight usually doesn't scare fish, in my experience, like scuba diving.
All right.
At night even, like when it's pitch black dark, I guess some fish would swim away, but the corals wouldn't change with a flashlight.
All right. Thank you.
Sorry.
Talking about Hoi Ha, actually, yesterday I had the confirmation for the 17th of April, so next week. I'm actually planning to go to Hoi Ha and meet with the people of WWF Hoi Ha in the morning, and I could stay part of the afternoon and take hundreds of pictures. I could take a couple of GoPros and take a few hundred pictures of the corals there, if that can be helpful. So at least we have our own sets as well. If some of you would like to join, Friday afternoon, go for a little swim, go for a snorkel, stay on the surface and takes hundreds of pictures as in the same kind of condition as the robot would collect them. Yeah. Is anybody interested in joining next Friday a little swim?
Sure.
Yes.
I will. I assume I saw your email. I thought you were tying up an online meeting. You'd be swimming. I mean, taking photos in person.
Yeah, but now that there's a possibility or there's a need potentially for collecting more data from Hoi Ha, and you guys seem to agree that it's a good site, and because we have good connection with the WWF, then I'm thinking instead of doing my class remotely, I might go there in person, and then stay on site in the afternoon, then to swim, snorkel.
Yeah, we know Pia. She's
yes.
managing. Yeah. She's very good. She's also marine biologist.
So yeah.
She's also a biologist.
Sorry.
You said that she's also a biologist.
Yeah, she's a marine biologist. Yeah.
And this is next Friday, so like a week and 2 days.
Exactly. So I will be there from probably like 10:30 a.m. because I'm teaching class at 11. But I think after 1, I'll eat on the site, whatever I can find. And then during the afternoon, I will bring a stand-up paddle board. So like this, I could and a bunch of like battery packs for my camera. So I could, and a bunch of SD cards. So maybe I can, let's see how many hundreds, I'll aim for a couple of thousand if I can, but let's see how long I can last, and batteries and SD card space. I think I'll activate my GPS tracker on my iPhone, and I'll just keep it on the deck of my surfboard, and I'll just take lots and lots and lots of pictures from the surface. I think that's how I can pretend to be a robot.
I've actually had to do that before, to actually map by hand manually a coral reef before. So this robot would be very helpful.
How did it go? What was your experience doing this manually? Was it coral reef check?
Snorkeling and scuba diving, and you have like a map of the area on a dive board, and then you weren't doing the species, you were just doing like reef check, like hard coral, soft coral, or what kind of substrate, and if it was diseased or healthy, type observations. But we had to like make a grid on a dive slate and then like go out and do the GPS points. So, and that took like 2 days, and that was like 20 by 20 meters. So
That's crazy, right? Like the amount of time it takes.
yeah.
And the conditions were good. Visibility was good. The current was not too strong.
Yeah, this was in Cambodia, so it was nicer water.
Okay.
So yeah, the next Friday, that sounds great. I'll be there. I'm sure Maxine.
Yeah. Sure. Yeah, we can tell Pia we are going to.
Cool.
Me too. So we're coming up to an hour. So I just wanted to check in with people like Elliot and Paul. If
Yeah, sure. Do you want me to present myself?
Yes, please do.
Okay. So I'm a student in electrical and electronic engineering. So I'll start to help you guys shortly. I mean, as soon as I can. So I could focus on the software kind of IT, AI stuff, but I'm also keen on helping on the Raspberry Pi. I've never used one. I've already used like an Arduino. I know that it's a little bit more difficult, but I'm sure I can like manage to find what can be done. And I guess that's it.
Thank you.
Thanks, Elliot.
So you mentioned that that you worked on Arduino. What kind of project did you work? Was it mostly mechanical, or did you some?
No, it was a beehive monitoring system. So basically, we built like an autonomous beehive with like some temperature, weight, activity sensors, and so we were connecting all the sensors together with an Arduino, because it was a lot cheaper. We had like a very strict budget, but that's how I spent some time on it.
So you're not using a camera, right? Because Arduino is very low bandwidth. So you're using
No.
sensor or like a laser gate or something like that to count bees.
Yeah, were you using an infrared like we had like to make several holes with like different infrared, and the infrared were connected together to return bees were going out and going in. Basically, they were triggered at different time, and that's how we calculated. But it was an homemade census. We built it from scratch. We didn't buy it. I'm not sure I was clear enough.
Thank you.
So for me, this past weekend, I was working with Michael a little bit on some of the schematic designs, but in light of the conversation today, I think I will reconnect with him tomorrow, sort of for looking for time to come through and either help with additional printing or modeling. But I'm definitely focused on that part and excited to see how we go.
Thanks, Paul. Yeah, we did miss each other, or we tried to sort of touch base.
No worries.
Yeah, just with the mechanical side of things, it's one of the more difficult tasks to do purely online or on GitHub. It's one of those workshop-based activities.
Yep.
But still, we'd love you here in PMQ, or soon we're going to be moving. Me and Jack have been working a lot from PMQ recently, but soon we'll be moving back to Chongwon.
To Chongwon. Okay.
Yeah.
All right, I'll connect with you and find a time.
Great. great. So how are we going with division of tasks? Do people feel like they have tasks that they can pick up with and or communicate individually with members in the team? So it seems like someone like Sarah, Maxine, and Sanju can talk independently or on GitHub. Ming and Paul will sort of always be in touch. Elliot and us, and says, do people feel like they know who to contact? Oh, I see some thruster mounts there. Yeah, I would love them. Yes. Oh, fantastic. You're on mute though.
Okay, here you go. So, it's supposed to be like, the hole doesn't really print all the way through. Is it meant to be like the hole down the screw? You're supposed to make the hole yourself, right? Almost like you have to open the pockets when you buy new pants, kind of thing.
Okay. Yeah, we can drill a hole. If it's a screw hole and we need to punch through, then I'll look at it in person. But that's great.
What is it?
That is to mount a thruster. And me and Jack were just talking about making a shitty quick one out of wood today. So having something with the holes in place and everything will save lots of time for the
and
next
especially
prototype.
since like the plastic, well, we'll see the I guess resistance might not be amazing, but like has the advantage of not rusting and not rotting, so it's cool.
And it floats.
Hmm?
And it floats? Is it full of air or is it like 100% filled?
Is it full of, oh, you're talking about that, right? Okay.
The thing in your hand will float opposed to...
Yeah, it's like, yeah, the density is not very high because also like when you 3D print, you know, I didn't put a full density. I mean, we can make it more dense, but this is like the regular setting density, so it's not completely through. It will float if it's a big pot of water like the ocean.
Excellent working. So we'll have to talk privately. Well, it doesn't have to be privately. How we can, you mentioned in a chat the other day that you would come in to PMQ, or you said no.
I don't remember that conversation, but anyway,
maybe it was just wishful thinking on my behalf. Yeah.
Okay. Well, like if you now, I just fix my 3D printer. Like I can right now. Like, do you guys have that issue where you can't print stuff? If you can, like, I'll just print it for you.
That's fantastic. We will send over stuff when we're ready. But there's two parts in your hand, like the acrylic disc and the thruster mount. That's fantastic. We can't wait to start prototyping with that. So yeah, let me have a think and maybe I'll come to you or yeah, get those parts. Thank you so much. And from anyone else, any sort of updates or wrap up tasks that we know we can continue with? Great. Well,
just a question. So if I'm going to be coordinating with the expedition next Friday, I would love you guys, whoever is going to come, please, or if you just tell me now, and I can just write the names and I'll communicate with Pia. So she's not like, who are all these people? I mean, I think she knows most of you guys, but just so I give her a heads up. So there's Maxine and Sarah, and then who else?
Michael and Jacques, I think, and Ming.
Okay, Jacques, Ming, so Cesar, Maxine, Sarah, Jacques, and not Michael. You're not coming, Michael, are you?
Yes, yeah.
Oh, okay, sorry. Okay, so then I will send you separately email to coordinate for the transport because you can't go there by car. You have to take like a minibus and stuff. It's quite far.
What's the location again? Sorry.
I'll send you all the details.
Okay, cool.
Yeah.
Okay, because I put in the meeting minutes in case people change their mind by then.
Oh, okay, yeah. Thank you.
Thank you.
Okay, well, I think we can sign out, but thanks everyone for a very productive meeting.
Yeah.
Thank you.
Thank you.
Okay,
Thank you.
Bye-bye.
Bye.
Bye-bye.
Thank you. Bye.